Hello everyone. I think you should be able to hear me now. I think my microphone is working okay. Cool. All right. Thanks for being with me today on December 5th, 7 p.m. Eastern Standard Time. My name is Pisek Benz. I am from Kirsten, and today is a special webinar. It's going to be about LLM app development. I think it should be for beginners, but let's see how it's going to go. So let's get started. Switch the camera here. Somehow this thing just keep moving. Okay, the agenda for today is going to cover really quick use of Ollama, LangChain, Gradio, and I will close up with actually the basic RAG or Retrieval-Augmented Generation, and touch a little bit upon effective prompting that you would need to build LLM application. As I have mentioned, these are the tools that we'll be working quickly today, and we are going to actually build 3 applications. I'm showing you 2 here. One of them on the screen is going to be about a YouTube summarizer where we'll pull transcripts from YouTube, and we will ask the LLM, especially Llama 3.2, to actually summarize the content for us. It can be a few hours long a video. It has no problem. The last one, we are going to see a demo that I make the LLM to act as a receptionist, and this is going to be a RAG or Retrieval Augmented Generation application where you have information about your in this case a virtual cafe. The LLM doesn't know, so you need to make your knowledge base and make that available for the LLM to retrieve the information and answer to the customers. So I think most of you have already subscribed to my YouTube channel, but for newcomers, if it's the first time that you see my channel, please subscribe to my channel, Kirsten by AI. We are on YouTube, LinkedIn, Facebook, X, and Substack. All right, so quickly about Ollama. Ollama is a lightweight application that allows you to pull open weight models from the internet. And what we are going to be using today is Llama 3.2. And this thing is running in your local computer, and it's in the way it works is that it communicates to the LLM using an OpenAI compatible API format. So once you make your application with Ollama, you can easily swap to OpenAI to scale your application using a larger model or something like that. These are the 2 commands that you will use. Once you install Ollama, you will pull Llama 3.2, basically download Llama 3.2 to your laptop or your machines. It could be a actually physical machine or a cloud virtual machine as well. Now, if you want to run Ollama as a server, you just need to call Ollama serve. And just to take note that if you run it on your local computer, this is going to be the endpoint that you need to provide it to your Python programming script so that it can actually call the right endpoint. Yep, this is how the OpenAI compatible scheme looks like. So when you call a model, you will provide a model and a list of messages. Usually you start with system message, prompting or priming how the AI should behave, and then you come up with the next message, and this is going to be the user message, and then you can keep going in turns, but usually it's going to be like it starts with the system, and then the user, and then AI assistant, user, AI assistant, and so on. So this is kind of like the format for OpenAI compatible API call. So right now, before I actually go to the go to how to use or serve the Ollama, I have a dedicated YouTube video for Ollama specifically. You can take a look in my YouTube channel for further information. But today, here I have downloaded Ollama already to my laptop, so I can call Ollama and I will see all the commands that's available in terminal. Usually, by the way, I'm on my Mac. If you download it, it will likely be a button up there, an icon up there as well. If it's there, it means that it's active and you can use it. But usually I don't like it. I like to use a command line in terminal. So what I can do here, I can do Ollama list, and you will get to see that now I have a Llama 3.2 models on my laptop. This is the latest open weight Llama model out there that you can pull from the internet. It has this one is a 3 billion parameter size model. So usually it's like Llama 3.1 and it's like 7 or 8 billion parameter. It's quite big, but now it's only 3 billion parameter. It gets equally smart. And by the way, my machine is MacBook Pro, M4 Pro, the latest one. So it's really quick with this local LLM now. So I can show you now. Let's see if I can remember the command line. So with this command line, I am pulling Llama 3.2 LLM and I can interact with it. Hi, I'm Ben. How are you? Like this. As you can see, it's really quick in terms of response. Could be that the model is smaller and my machine is very fast as well. So I am going to exit right now. What we actually need today is I am going to serve Llama as a server, and it's as easy as you say Ollama serve. Oh, it's already bind because this guy is still active here. So I'm going to quit this guy again and serve. Now this port that I mentioned to you now is live. I'm sorry. Should be somewhere here, embedded in a lot of messages here. But anyway, if you can't catch it in this bunch of text, this port is now live connecting to Ollama at the endpoint. Okay, now so we can move on to our actual framework that actually makes the LLM app for you. I will actually recommend you guys started looking into LangChain and LangGraph. To be honest, over the past few years, it's been so that there's so many tools out there. It's just mess and chaos out there. But now I think it's getting to consolidate to what tools that people should use. And in my opinion, LangChain and LangGraph are actually one of a strong propositions to use in terms of Python programming as well, to use to start building your LLM application. So yeah, it's getting started very messy with just one component, the LangChain, but with many problems that now it encountered, it had expanded into other framework as well. LangGraph allow you to actually create agents. We are not going to talk about agents today. I will have a dedicated session to talk about building agents application, but everything is based on a solid understanding of LangGraph and LangChain and LangGraph. And they also come up with production grade tools like Langsmith, which allows you to actually monitor, test. So this is actually like full features about testing and monitoring and going to production. LangGraph is an extension of LangGraph platform. Is an extension of the LangGraph. So if you want to develop your agent-based, very complicated system, I think you should go with the LangGraph platform. But this is in commercial level. They are gracious enough to provide us with free tools like LangChain and LangGraph, for example. All right. So it's going to be the basics today. The core of LangChain is that you are going to define your LLM. You are going to use templates because you want your application to be flexible, right? You want to be able to inject new information when you serve this customer, and when you want when you serve another customer, you want to inject their that particular customer's information to your system. So the template is important. And last but not least, if you don't have memory, you cannot have a conversation. So we are going to actually touch a little bit upon LLM definition, templates, and memory. Now, in terms of the turns of conversations, there are right now two main types. The first one is very straightforward. Human message, AI knows what to respond and reply back, and then the human start a new message again, and the AI replies. On the second one, it involves tools. This is a little bit getting into agents now. Agents are an AI that we provide tools for it to do something, like calculate this for me. So that AI is going to call a tool, a calculator tool, and once it gets an answer from a calculator, it will then provide the final response to a human. So this is the second type right now that we know most of the time. All right. Oops. Okay, now let's get a little bit hands-on. So let me bring my code right up here. Okay, so by the way, this is going to be on my GitHub repo, and you will be able to access it too. Actually, it's actually in there right now. So you can go to GitHub, case done, and this repo is a LangChain first step. All right, so let me get started quickly with a overview of how LangChain works in this Jupyter notebook. Scroll up to the top. Here we go. Let me clear everything, selecting a kernel. Is it this one? I think so. All right. Okay, you are going to load up everything as necessary. I provide, sometimes I will use OpenAI API key because if I want to use like GPT-4o or 4o mini, which has, I think, more brain power than the Llama 3.2 free version, I would just keep my OpenAI key inside a file and under a folder called secret, and then I will load it up. So yeah, I'm loading my OpenAI key right now. And so right now, chat OpenAI is from LangChain, right? So this is going to create an instance that communicates to OpenAI server, and we are going to specify it to use GPT-4o mini. So defining a model is as simple as provide a model and provide an API key. This is for OpenAI, for example. So yeah, right now I have a link to OpenAI API server, and now you see the message. The LLM application is simple, right? You see the message. If I go back, this is an OpenAI compatible message. You have messages are a list of message. Each of them has a role in it. Now this one is role system. This one is role user. It's similar in LangChain as well. You provide a list of messages. This one list is this is a system message. I just tell them to be a parrot, and this is a human message. A human message actually say hi. So this list gets passed to a model, right? In a similar manner to this one, we are providing lists of messages and send it off to OpenAI server and compute back. So let's see what the response will look like. Now I have got my response back, and this is what the AI from OpenAI server say. Ahoy there, matey, what be your can't even read pirate stuff, but anyway, it's correct. This setting is correct. And if you want to dive a little bit deeper, you can do .dict. You will see what the response object has. You have content, you have token count, so you can actually implement your own custom way of collecting how many tokens you have been used for this application or chat. This is another one that has token counts here. By the way, we are going to get a little bit fast today, not my usual pace, because I have like many tools that I want to cover for you. All right, so next one is a prompt template. You can call chat prompt template. This tool, this class is actually for preparing a template for chat. You have a system prompt at the top, and you have a body of conversation between you and AI, right? So this is the main usage of a template for a chat. So you call it in here, and then for this application, my system prompt is translate the following to English, from English to ... language. And now you can see that this one is a placeholder. So we are going to fill in what language it is later on, because right now we are working with the template level. If you execute this one, you have a template. It still has placeholder. It cannot be rendered right now. It cannot be actually sent off to OpenAI because you still have two missing placeholders, two placeholders that don't have actual values, like language and text here. In the same manner, you can use .dict to see inside. And the way to actually fill in the placeholders is actually use this method, invoke, and you use a dictionary to fill in information of these placeholders. Now, I'm filling in those things, and I can see what the actual message looked like. Now, this message with filled in information will be like, okay, English to Thai, and the actual message is, hello, how are you? Now, because I'm Thai, if I run, I should be able to see if this is correct or not. Now, the response say here, สวัสดีครับ คุณเป็นอย่างไรบ้าง It means, hello, how are you? So that is correct. All right. Okay, move on. So we have covered LLM definition. We have covered the template. Now, the last thing that you need to actually make a conversational chatbot is the memory. There's an old way of doing this before LangGraph emerged. The old ways is actually pretty much this, guys. A list of messages. You need to come up with a way to insert, append new informations or new text from either an AI or a user into a list. But now, this incarnation, a new framework, LangGraph, was actually created by the LangChain team, and LangGraph is recommended over an old way. So it LangGraph implement a state machine. So it has an underneath mechanism that automatically insert or append new messages to a conversation, as well as you see, as well as keeping many messages in parallel. Anyway, so long story short, you import here. You need to create a graph now, and a graph is actually consists of nodes, compute nodes, or conditional nodes. They are a components of a graph, and for each node you can assign a function. That node can call a function. In this case whatsoever, there is a node called model, and we are equipping this function to that model node. And pretty much inside this call function, as we did before, we are sending messages to a model to compute. So this is how the very simple graph will look like. It will start here, and you are going to be with the model forever. You send message to the model, you get the message back from the model. And this is our graph, just one node, and it will keep going on forever. Now, if you recall, I mentioned LangGraph implementation of message state allow you to actually keep many conversations together, and this is done by a thread ID. You will need to pass in a config object into a graph so that it knows what kind of message chat history stack it needs to pull and keep going on our conversation. So all in all, LangGraph is a better way of handling chat history, but because of its enhanced feature, it comes up with a boilerplate that you need to follow, like here. So, all right, let's have a conversation. So I am going to start off with, hey, I'm Benz. There is only one message in here. And the response I get back from, I think this case in OpenAI server is, hi Benz, how can I assist you? Now, if I ask a follow-up question of who am I, if the memory works, then it should be able to reply that my name is Benz. All right, this is the response. Yeah, your name is Benz. Blah, blah, blah. That's it. So this implementation of memory stack works. Here we go. And if you actually come take a look at output, you can see that there is messages attribute that actually consists of the message hands-off between human and AI. Now we have 2 turns, so in total of 4 message items, like human message, AI message, human message, and AI message. Same way, if you come to a memory and dict, you can actually see what's inside, and you can then develop your app later. Now, back to what I was mentioning before, chat prompt template is a template for chat. And as you can see here, usually we start off with a system message, and now you have a placeholder that will need to keep information of the chat, right? So we are going to create the prompt template. Now we are going to create another graph. Here we go. Nothing much here, guys. I'm just showing you how to use chat prompt template. Additionally, we implement history in here. So if you recall, in the call function, this guy doesn't have a memory yet, but luckily this message state help us manage the memory. Now it's for the chat prompt template is an enhanced way because it allows you to specify the system message to be like so. Now, if I'm going to show you, it's different from before because I said, okay, the system, you must be a pirate. Then here is the behavior of the system. The first message I sent is, my name is Pisek from Kickstart, and this is the response from the AI. It's in pirate language. So yeah, the system message here, the system message gets implemented correctly with the chat prompt template. Okay, now I am going to pack everything into an application, and I'm actually going to provide you with information about Gradio later, but pretty much here, this is my prompt template. I upgraded from just simply be pirate to a huge one. This one is actually I said to AI, your name is Echo. You are AI coach, and you will help me going through personal reflection, if I may. That's my system prompt template. Now, with the boilerplate of LangGraph to implement a system message, as you can see, it's the same as before. I have my application that is ready to be packed into a Gradio language and launch this thing. So now here is my Gradio. So pretty much, this is my Gradio, guys. Gradio use chat interface. Call this function, where this chat function actually invokes my application right here. And this, my application has LLM, prompt template, and memory. And that's it. The rest is just, handling variables, stacking memory somewhere that I know. So here is my Gradio application launched inside this thing. I can click this and it would jump to a browser. But what actually what I want to do is I export everything and craft everything into a one Python file. It's exactly the same as you saw before, but one little change is that I'm going to be no longer using OpenAI. What's different here is I am going to use my Ollama server on my laptop here. So basically, I'm not using this guy. I import this guy instead and use that. Okay, everything else remains the same. System prompt, boilerplate of LangGraph up until this point, and the Gradio interface. So now I should be ready to launch. Okay, so the way to launch for me, I switched from using Conda to Poetry to keep handling packages. Okay, boop. Here we go. Now this one should be live. Oh, I don't have this one open. Here we go. This is my application. Echo, the LLM coach. If you click this one, so now it's loading Llama 3.2 to Ollama, and now it's served, right? You are considering consulting with me about a career. What have been on your mind lately? What specific aspects of your career are hoping to explore? I want to become awesome AI developer using LangGraph. Here we go. The second generation is completed very quickly. Summary. I hear that you are eager to be a blah blah blah. To clarify further, can you tell me what specific challenges? So pretty much it worked as I intended for it to be. I'm going to kill that application right now. So yeah, guys, LangGraph or LangChain, it may look intimidating. Yes, I don't think it's that easy, but yeah, if you can, I think you can master it. Just going to go through a lot of its tutorials on its website, and sometimes it's very unorganized. But yes, I will recommend you guys going down this rabbit hole, LangChain and LangGraph, if you want to build your LLM application. All right, back to our slide. Now, Gradio allows you to make quick user interface to test your idea. You can ship it off to your client to let them play with the workflow and your thinking, and yeah, it's actually very good at doing user interface very quickly, and I use it often, even at work as well. So pretty much quick UI for AI and machine learning. It as you've seen before, very quickly chat interface, ready to use, or you can actually customize with blocks. But essentially, the core idea of Gradio evolves around defining elements on your user interface and trigger events, a click event or update in the text box event, and then do something about those events, right? Okay, elements. The way you will use it is you will define the attributes for the element you are looking into. Like for a text box, you can define how many lines it should show. This one line, or you want 2 lines, maximum 50 lines, and so on. But what you need to know quickly is that elements can act as can act as an input to a function, or can act as an output to a function. And in Gradio documentation, it has a description of what would be the value if the element is acts as a input, or the value if it acts as an output. For example, in a text box here, if a text box is an input to a function, you will get from that, what you get from that is a string, right? But if a text box is an output from a function, it will be a string. So yeah, pretty much take a look at the behavior of the element in terms of being an input or being an output. Events actually cause a function to trigger. This is an example. So I have 2 text boxes, text box 1 and text box number 2 here. I want this guy to be an input to a function, and I want text box 2 to be an output from a function. And this is the button. When the event that I want to monitor is button click. When the button click, it will trigger this function. So I need to define this function. This function will take in text box 1 as an input to that function. So when the text box 1 is acting as an input, it will give a string to the function. Now inside this function, I may write a way for the LLM to judge whether it's a positive or a negative message, sentiment analysis. And if it's say positive, it will return a string positive and push it back, push the response to text box 2. Text box 2 will receive that string and update itself. And this is what it is, guys. So eventually, what you need to think about is what event happens and what are inputs to a function that will get triggered and what will be the output. That's pretty much it. So to see how that works, let's get a little bit deeper in coding. Actually, this is going to be very huge coding, but I will walk you through as smoothly as possible. So this is one of the repositories on my GitHub as well. I did it like a few months back, not a few months, like several months back, and now I upgraded to be a better version. So the idea behind this application is I want to summarize YouTube or many other things, right? But right now I focus on YouTube's. So in a summarization task, you have your source that you want to summarize, and the source can be from a text files or PDF, Excel, but in this case, YouTube video, right? Whatever it is, whatever your source is, you want to upload it and you want to summarize it. And usually, if this is short enough, you can do it in one go with a prompt. You can implement it in LangChain or just simply throw it into a ChatGPT, right? But the problem is when this text gets long, forget about non-text elements. If this text gets long, it will exceed a context window of the LLM. So there's a method called map reduce. Pretty much you are going to split a really long text into chunks, and you summarize each chunk individually in isolation. And afterwards, you go into the final step where you are going to summarize the summaries again to craft your final summary. Oops, sorry, there is a... okay, I thought it's a question. Okay, great. So yeah, the final step is you are going to summarize the summaries again into a final summary. So now let's get to the demo. So let me bring my demo up here. just kill this guy. And not this one, this one. All right, so this is the YouTube summary, summarizer code. It's actually a lot, but I just want to touch upon the point. Where is that? That what you need to think about is mapping. The event that is got triggered call what function, and what is the input to that function, and what will be the output to that function. Okay, so this is oh my god, it's long. This is my Gradio block. I customize it, right? Here we go. You know what? Let me just run. Okay. Poetry. Run Python main. Oops. Okay. Everything is served with Ollama. Not to mention. Oops. Wow. So many typos today. Okay. All right. So this is the YouTube, the upgraded version, guys. So if I click this one, it's going to clear everything. Let me show you this button, get information. When I click this, this is the input to a function that will retrieve information from that YouTube and populate this these two sections. Here we go. Nothing LLM here, it's just clicking this button, pulling information from the internet. So where is it implemented in the code? Not this one. Let me just move this one back. All right. Okay, let me find a needle in the haystack here. So it's the first tab. It's the get button. Ooh. Where's the button? Can you see the button? This is a clear button. Here we go. This button. This is the button element, get information button. And here we go. When it's clicked, call this function. And the input to that function is the URL. The output is two text boxes called title and description. Where's the title? The title button is here. I'm sorry, the title text box is here. It's just a text box with label title, 2 lines, 5 lines max, and show a copy button. So here it is, guys. Just connecting elements as an input to the element as an output. Now, if I get the transcript, same thing happens. It will use this box, find the script, and populate it to this box here. I added a token count to actually see how many tokens inside this. So, you know, let me grab a really long YouTube video from Andre Kapathy, I think. Let's see. This guy is great. He's a very smart person. So this is a podcast. I think so. That is really long, 3 hours. Dump this guy in there. Get the information. Andre Kapathy ended with 333. Is it right? Yes. Descriptions, you can see it here. Get transcript. Not doing any LLM here, guys. It's just calling YouTube API, and this one has 43,000 tokens in it, and it's really long. Yeah, god damn it, it's really long. All right, so what I really need is to summarize this thing. I click the summarize tab here. Now I upgrade it to have chunk size, and sorry, this is the same thing. Chunk size and overlap. So let me just say 200. So pretty much this tab, sorry, if it's too small, allows me to where is it? To define how many chunks I want to summarize in the first step and finalize it again later. So Now I upgrade it to be here. In the map phase, pretty much from chunks to initial summary, you can have your prompt here, custom prompt. For example, right now my custom prompt is write a detailed summary of this text section in bullet points. And the last one is write detailed summary in in bullet points. I would just make it pirate. No. Use emoji. Let's see. Okay, so I am going to let this run because it's a really long YouTube video, and when it's being run, I will explain my code to you guys. So I click summarize. Now it's clicking everything. Sorry, it's cooking up everything inside it. Ollama is being used, so I'm happy with it being in progress right now. So let me come back to this one and walk you through the code. This code is, as I mentioned, I have a map step template text here, and combined step. Combined step is, I refer to this part where you summarize the summaries again, template here. And this is the function that will get information from the YouTube video. I'm not doing anything fancy here, just lots of parsing and using this guy as a parser and get information from the internet. Thank you, Claude, for helping me writing this code without any trouble at all. Text splitter is used for the LangChain splitting mechanism there. Get YouTube transcript, get Ollama. So I'm using Ollama as you mentioned here. Where did I get it from? I get it from LangChain Ollama library. Where was I? Get transcription summary. This is where the magic begins. So first I get the transcript. The transcript is here. I need to transform it into a document object, and this one is a LangChain core document. I need to split documents into chunks, right? So pretty much doing this step, making chunks. With that, now I define my LLM, get my map prompt template, right? Here we go. Combine prompt template and put everything into this function. Load summarize chain. This is a function provided by LangChain people. It allows you to easily connect the LLM to the chain type map reduce that I mentioned and the prompt. So everything will be done. This whole thing will be done underneath this guy. And yeah, you can just call invoke and it will run everything, and the rest is just my Gradio interface code. And you see all the buttons I need to link. I am watching the event of the button click. So this button click, get this function. This button click, call this function. Get this button click, call this function. And the clear function is add all the elements inside the Gradio interface that you want to clear out. So yeah, once this button is clear, once this clear button is clicked, it will clear every element inside this list here. So button element, the clear button is a special button that has a click element definition done already. Oops, oh my god, embarrassment. What is happening? That's an error. Okay, yep, live video. Oh, I see. I don't have a transformer install. Okay. Really embarrassing, guys. Okay, let me try it again. Okay. Come on. Okay, I can come in here, refresh, get this link again. yeah, if everything goes smoothly on live video, it's going to be a surprise. All right, so 200 overlap size, prompt template. I will say add emoji, a lot of emojis. Okay, hopefully that is not embarrassing anymore. Let's come back to this later. And by the way, you already have this guy on this repo on my GitHub, so please go and take a look at that. I have spent a lot of time upgrading it for you guys. All right, next topic is going to be prompt techniques. Why is it important? From Enduring, he recommends us starting with using prompt rather than fine-tuning a model. You can go a long way with prompt, and therefore you need to learn how to do it properly. So from the past year, I have figured out that I only need 6 of the techniques to go several miles with prompt engineering. First one, you need to have your main components of the your main components of the prompt correctly. Task, what task you want the LLM to do, the context, what information you need to provide for the LLM to do it well, and output, what kind of output you want. Now you can enhance it with acting as a ... to do that well. Acting as a senior data analyst analyzes data for me. That's the second the second technique. The third technique is where provide structure to your prompt. Acting should go first, instruction should go last, because there is primacy and recency in the emphasis that the LLM will put to the prompt. You need to provide XML tags if your prompt is so complicated. So it's about structuring the prompts to be clear. What section is what for the LLM to know. Chain of thought, usually it's better to write instruction in steps so that it doesn't go off-road to do things on its own, or just say, let's do step by step. But for me, for making LLM application, don't give the LLM a lot of room to work. Provide steps so that it follows through. Number 5, giving examples. This is a great way to make sure that the LLM follow what you want. The good answers, the bad answers, as well as providing guardrails for what not to do specifically, at least in the prompt regime. Last one is reflection. Usually I use this with ChatGPT, where I can say that go back, redo your work again, or find an improvement to your previous response. But when you are building application, usually if it's a flow, you don't have means to actually reflect back, right? But you can create another LLM, another AI to challenge it back automatically as well. But you need to make some scaffold programming around it, but it can be done. So yeah, this is my 6 techniques. I think most of it are actually in this YouTube video of mine on prompt engineering as well. So that's about prompt engineering. So let's go back to this. Is it actually successful? Okay. Actual conversation provided to the context. This is embarrassing, so it doesn't really work. Okay. What did I do wrong here? Okay, well, need to spend time fixing it, and I'll let you guys know. Can't think of it right now on spot, but okay. Let's move on to the last one. Cafe chatbot with RAG. So this one is going to be about, as I mentioned, Retrieval-Augmented Generation. The problem with the LLM is that usually it's trained to a certain period and we need to freeze it, right? So it doesn't have an updated information, or it doesn't actually know about your organization. So you need to provide some information for it to retrieve. This is a way to actually reduce hallucination as well. So basically, if you have a question, you need to provide a context and you instruct it to be using this context to answer to the question only. So the way for RAG framework to actually work in deployment when interact with the user is that the first step is you need to index your knowledge. You have how many documents you have, you load it into chunk and you provide embeddings and keep those vector embeddings in a database. Now, that's your knowledge base or vector embedding database, right? Now, in the actual serving time, user query or user questions comes in, you will find in your embedding database what piece of information you need to retrieve and use it as a grounding for the answer. Now, that's a retrieval stage. The last one, with the retrieval stage, and you have kind of like a final prompt right here, you ask the LLM to answer, generate the response. So you have to do three steps here, and that leads us to the last demo. So this one is also on GitHub as well, and same thing, I have upgraded to the latest Python 12 version, I think. So here we go. We are going to, oops, oh my god, that's huge. Yeah, we are going to make a chatbot for our cafe. So the information that I provided, the knowledge that I provide to the LLM is inside this folder. We have general information, which is, let me just clear this guy, which is the name of this the cafe, what we sell, operating time, location, branch number 1, 2, 3, and payment, right? And also have menu price, menu and prices, drinks, espresso, this much, small and large size, and products fact sheets like geisha or blue mountain, everything. That's the knowledge base that I want this bot to learn and answer to user questions based on that thing. So the first step is indexing. So let me just go through quickly. Here we go. I'm not using anything OpenAI anymore. So let me clear. My database, I just deleted it. But if my vector embedding database get correctly created, we will see a folder called Chroma over there. But right now, I just delete everything. So I'm using Ollama embedding, the same way with what we do before with Llama 3.2. But instead of Ollama LLM, we are going to use Ollama embeddings from LangChain Ollama. Yeah, that's pretty much it. The rest is just loading stuff from the file. Here we go. So these are the files that will be processed and put into the vector embedding database. You're following through. Now it's converted into documents. Now then we are going to, and this step is going to create a vector embedding database, go through the chunk and use the embedding LLM to produce embedding and put it into a Chroma vector embedding database over there. So yeah, this is your indexing step. Now retrieving step, let me just restart everything. These are not used at all. Okay. So you can now load your vector embeddings database that you just created from this step, right? Bringing things back, and now you can retrieve. So let's say the string, the text is opening hours. It's going to retrieve some information for me. here, this is the result. The result from bringing vectors that is similar to this query is the top one. This is the most relevant information. It actually says, oops, it's actually general info document, right? I think if you recall, operating time is here. I'm not even saying operating times. I'm saying opening hours. So it's actually matching opening hours to operating times. And this seems to be the most relevant document that is retrieved. You can provide how many documents you want to retrieve, and a better retrieval mechanisms called maximum marginal relevance. You can use that too. And yeah, that's pretty much the retriever. The retrieval stage will just bring back the document that it needs to use to answer. It hasn't generated the final answer for us yet. It's in the last step. So let me just pull the last step up here. Restart. There you go. So loading, defining my embedding data, embedding LLM, because as if you can recall, we need to do this conversion to compare embeddings. Now I load my database. The database is just a database, and I want to transform this database to a tool that I can equip to the LLM. Basically, I need to transform it into a language that I want to transform my tool, my function, to a language that the LLM will understand and be ready to use. And this is a way to do it. Create retriever tool. It's going to transform this thing to a function that the LLM can now use. And you need to provide names and description. The description should be explicit, so the LLM will know that this tool is good for what, and it will be able to correctly use it. Now, when I created this repo long time ago, it was agent executor that's all that rage there. Now it's been put on shelf. Recommended to go with LangGraph instead. So we are going to use our knowledge of the LangGraph that we did before here too. You define your LLM, you define your tool, and you define your system message here, and there is a function allowing you to transform all of this thing into an active graph agent. So we use that, and this is how the graph of our application looks like. Start, we meet with the agent. You send the information to the agent. The agent determines if it wants to use tools or not. If it doesn't need to use tool, it will answer. Otherwise, it will trigger tool, get information from the tool, put it back to the agent, and then answer. So this is how the graph looks like. So let's test. So my query is, I am Ben's, hello. And you can see here, in a minute, I think, it did some retrieval and then response. And this is actually what has been done underneath. I'm saying, my name is Ben's, hello. AI thinks that, okay, I need to use tool. So it go do some tool and get back information from the tool. This is a document that it thinks that it needs to use to answer to my questions. And eventually it did something. Hello, Ben's. Welcome to Planet Box. So it actually used the name from the context to answer it to me. That's great. If I asked what is opening hours, now trigger the tool to find what sources has information about opening hours, and responded back to me. Ben, the opening hours for this cafe is so on and so on. Yep, that's pretty good. Now we can keep going, I think. All right, what's your name? Retrieve information, and its name should be Echo. My name is Echo. Right, great. Okay, now you're ready to wrap everything into a chat interface using Gradio again. Just redoing all the parts above, you know, like defining config, LLM tool, system message, and a boilerplate for LangGraph agent executor. And a chat interface and chat. That's pretty much it. So again, I packed everything in a main .py. Nothing much. I added logging in there, but everything else remained entirely almost the same. So let's chat. Python main.py. I run a little bit over time, but thanks for staying with me. Almost done, guys. So let's see. All right, Echo, the Planet Box receptionist. What's the menu for today? I don't specifically have menu of the day yet, but it should retrieve a menu for me in just the regular menu, right? Hot drinks, special holiday drinks. This is hallucination, 100%. I didn't have that, so I think even with a RAG, sometimes hallucination still happens because you guys know that it's just LLM. It's non-deterministic. It can go off rail really quickly. What is opening hours? But should be the same answer as before. Okay, opening hours. Well, just like give me a lot of information here. How much is cappuccino? Okay, 2 P's. Okay, let's see how much is cappuccino. Oh my god. Cappuccino is 3 for small, 4.5 for large. Yes, good one. Thanks. Okay. Yep. Again, this repository is on my GitHub as well. Yep, that's pretty much it, guys, for today, for this workshop. You have seen Ollama, Gradio, LangChain, LangGraph, and RAG application. Let me fix the YouTube summarizer for you guys and upload it again to the GitHub, but everything after then should be ready. So thank you very much for staying this far. If you please kindly help me get feedback on my webinar today, that would be I would be really appreciated. And in this feedback, you will see topics that I plan to go deep dive into. So please provide what you think. It's going to be a good step forward, and I'm going to be really appreciated. Thanks a lot, guys. So today we have done LLM app development for beginners. See you next time.